Welcome to this introductory video to BASiL. BASiL, which stands for the Bunkering Area Safety Information LNG, is a piece of proprietary software that allows the calculation of the size of the safety zone accessible via the SGMF's members' online portal. This was developed by an SGMF working group of industry experts to provide consistent guidance on the impact of bunkering leak scenarios to participants and competent authorities. All this is within the SGMF publication on controlled zones. BASiL provides guidance on the safety zone required in the event of an LNG leak during the bunkering process due to a hose or fitting, flange, fault or incident. Using data submitted via the online portal form, BASiL provides the user with a data set and diagrams demonstrating a three-dimensional space which may be impacted by a leak of LNG during bunkering, where special precautions are required and access restrictions are also required. This is to enable the reduction in potential consequences in the event of a leak. The size of the safety zone is determined by the worst consequences of a defined leak. And the opinions and calculations are based on international hazard data for LNG and operational norms. SGMF has reviewed all possible bunkering leak scenarios to identify the maximum distance of impact sufficiently to potentially kill an individual based on an assessment by technical experts of likely leak scenarios. Potential hazards identified as a result of leaks. Well, firstly, we have pool and jet fires and explosions. Fires and explosions, why they are fatal in a very small area, their extent is relatively close to the leak source, so minimum consequences elsewhere. However, gas clouds and flash fires, these flammable gas clouds may extend over significant distances, and if it ignited, are likely to kill those within the cloud between the point of ignition and the source of the leak. This is a test at Rely on UTEC's facility in Rotterdam in the Netherlands for one of the local fire services. What you see here is a pit full of LNG, and that white cloud is gas boiling off from the LNG and condensing water vapor in the air. We can see that water vapor is very heavy, it runs along the ground and has trouble getting over that earthen bank. What we see now is a fireman with a naked light, dropping it in there. So we're going to create a gas cloud and ignite it and see what happens. But this is the hazard we're mainly concerned about with LNG. You can see the pit at the moment, there's not much heat ingress, there's very little gas coming off it, it wouldn't ignite. Fireman's about to put some water in it, put some heat in, and you'll see the gas cloud grow. Watch the gas cloud as it goes towards the ignition source, and it will ignite and burn back to the pit, which then becomes a pool fire. So the concern is anybody in that burning gas cloud when it ignites. Today we're going to talk about the use of BASiL. BASiL is SGMF's safety zone calculation tool. So I'm just going to take you through how you write the input into BASiL. There are initial screens about procedure and about yourself to make sure your requests get back to the correct place. Then there's a screen on project information to allow descriptional information to be added. Why is it important that we have some idea of location? Because weather changes in different parts of the world. This is largely about latitude. The further north or south we get, the colder it gets. The closer to the equator we get, the more warm and humid it tends to get. So weather is primarily about latitude, but we have continental land masses like Russia or Saharan Africa, which also have an effect. So we need to put longitude in here. The actual location doesn't matter hugely. It doesn't need to be exact because we're talking about general weather and climate in a particular region. So next step, this is where our LNG supply is coming from and details about it. So the first thing we want to talk about is the pressure. This is the pressure in the road tanker, or in our case, the bunker vessel storage tanks. It's in bar gauge, bar G. That means it's a relative to atmospheric pressure at the time. So if I was looking at a membrane tank, I would be having a number less than 1, so 0.15, 0.2, something like that. I'm going to say this is a type C tank, so I'm going to put in a number of 3 bar G. That's the storage pressure. Storage temperature, if we know it, we can put that in. So there's a little drop down here, it says yes or no. Do I know the storage temperature? I don't at 3 bar off the top of my head, so I'm going to say no. If I say yes, we get another line where we can put the storage temperature in. But at no, BASiL will calculate the saturated vapor pressure of 3 bar occurs at which temperature, and will select that temperature. BASiL needs to have some form of LNG composition to allow it to work. We do that through net calorific value. It's a proxy. It's not exact, but in most cases it's good enough. You should know what your net calorific value is going to be. It will be on your bunker delivery note and in your discussions with the bunker supplier. Calorific value varies from different parts of the world. So we can see a list down here of the different regions of the world. So 15 degrees C, 15 degrees C, what does that mean? It means the gas is metered at 15 degrees Celsius, and after combustion is cooled down to 15 degrees Celsius. And all these different numbers mean different calorific values. And the error can be as high as 10% if you choose the wrong selection. So I said London, so I'm going to choose the UK one, which is 15 degrees, 15 degrees. I now actually need to put in the net calorific value. The units here are megajoules per cubic meter, so you might need to do some units conversion. Unless you've chosen the US, then the units will be BTUs per standard cubic foot. So I'm going to take a number 36 megajoules per meter cubed for my lower calorific value. Is the LNG density known? Again, we've got a drop down, yes or no. If we said yes, we can enter a number. I'm going to say no, and that way BASiL will calculate it on my behalf. And we'll move on to next step. Now we're going to look at bunkering full stop. So the first one, what's the bunkering type? We've got 2 effectively. We've got road tanker and bunker vessel. Well, I said in my text that we're going to have a bunker vessel, so I'm going to select the bunker vessel. How much volume am I going to transfer? So I'm going to say that that's 2,000 cubic meters. And I want to transfer that in 3 hours, so 180 minutes. Strictly speaking, we should be looking at the peak flow here. But over 3 hours, our startup and shutdown time is only sort of half an hour. So it's not going to affect these numbers unduly. But if you've got a very fast bunkering process, you might want to adjust either the volume transferred or the time to get to the peak flow rate. What size of hose am I going to use for that? Well, I'll get this deliberately wrong. I'm going to say a 3-inch hose at the moment. And when we move on, hopefully BASiL will tell me that is wrong. The transfer pressure. We need to transfer from one vessel to another. So we're talking about pressurizing using a pump. We need a pressure drop for flow to actually happen. Now, the transfer pressure has got to be higher than the supply storage pressure, which we put in last time, which was 3 bar. So I can't put 2 bar in here. It's got to be above 3 bar. And at the moment, we've got a limit on this of 20 bar. It's unusual, but some people are pressurizing LNG through very long hoses up to sort of 10, 15 bar. Okay. You must put in a pressure drop. You cannot put in 0. talk to your hose manufacturer. They will give you an indication of what it's going to be through your hose system. So I'm going to say 5 bar. So that's 3 bar in the storage. I'm adding 2 bar to that through my pump, and it's going across at 5 bar. Primary leak source, again, I've got 2 options here, a hose failure or a fitting or flange failure. And the selection here largely depends on what we're actually using. I'll talk about fitting and flange failures first. If we're using a hard arm, so pipes, fixed pipes with swivels between them, they are very unlikely to leak anywhere apart from the connections, i.e. the flanges to the bunker vessel, the flange to the gas-fueled vessel. So then you would take the fitting flange failure. Most times we'll be talking about a hose failure. So this would be a metallic hose or a composite hose. Here, the failure can be anywhere along the length of the hose, not just at its fittings at either end. If, however, you've got a hose inside a hose, so any leak from the internal hose is caught by the outside hose, you could probably then move that to a fitting or flange failure because the leakage will be at one end or the other. I'm going to choose hose failure. I'm going to move on to the next step. And I can't because I've got an error. As I said, a 3-inch hose is going to be too small for this. So I need to up that. 6-inch hose, and BASiL's happy with that. So we can then move on. ESD type, that's emergency shutdown. We have 4 scenarios for you, depending on what we're looking at. If you're using something like a road tanker, there may not be an automated system. So we're looking here at a man noticing that there's a leak, shouting at the man operating the road tanker, and that takes time for them to shut the system down. That's fully manual, 10 minutes. If one side is automatic, say on the gas-fueled ship, we've noted a gas leak, but we've still got a shout to the woman driving the road tanker to shut it off. We're down to a 2-minute leak. Fully automatic is probably where most of us are. It depends how you're going to detect the leak. Gas detection systems take time to operate, but we've also got a very fast and fully automatic system. This is going to have very quick closing time and to a certain extent will reduce the leak sizes. However, it takes control away from the ship about what is actually happening. So I'm going to choose fully automatic. Minimum hose elevation. We could lie the hose on the deck of the ship, either the bunker vessel or the gas-fueled vessel, or it could run along the quayside. The problem with that is we can't get any air underneath the hose, so any leaking gas will not mix with the atmosphere, and the safety distance gets larger. So what we really want to do is get the hose a little bit off the ground to get mixing underneath. Effects start at about 0.3 meters, 30 centimeters and more, and the effect runs out. So anything over 5 meters really doesn't matter. I'm going to put in 0.3 meters there. So I'm going to have my hose a minimum distance off the deck. Hose entry location. This is where your bunker station is on the gas-fueled vessel. It can be on the deck or it can be semi-enclosed. I'm going to select semi-enclosed this time, and it will ask me, well, how far beneath the deck is the semi-enclosed bunker station? So I'm going to say it's 6 meters down. Okay, that's all the data that BASiL needs. We're on the penultimate step now. Is the bunkering layout known? Yes or no? Well, I'm going to say yes. And we come up with the gas-fueled ship and the bunker vessel, and I can put in some dimensions there. So my gas-fueled ship is going to be 225 meters long, 30 meters wide, and the main deck is going to be 15 meters above the water. The manifold is towards the rear, but not completely so. I'm going to say 175 meters. And the manifold above the water, well, remember we put it 6 meters down, so it's going to be 9 meters above the water. 15 minus 6 equals 9. The bunker vessel, I'm going to say that's a bit smaller, 120 meters, 20 meters wide. Height of the main deck, 5 meters. It's going to be midships for the manifold, so 60. And the manifold's 2 meters above the deck, so 7. Distance between the vessels, let's have 2 meters for the fenders. And then the other big question is the configuration. Is the bow of the gas-fueled ship the same end as the bow of the bunker vessel, or vice versa? In this case, I'm going to say bow to bow. BASiL doesn't use any of this information in its calculations. This is purely to draw a diagram showing the indicative places where the gas will spread to. And finally, submit request. The request has now zipped off to the office by email. We'll then run the report and provide you with an answer within 5 days. 5 days might seem like a long time. Most times it'll be quicker than that. But if something's gone wrong, we need to have the time to think about it and work out what went wrong and come back to you and ask you, well, did you mean to put this data in, or find some other way of solving it? So that is how you get the request into the system. Okay, so once the report has been run, you'll get an email from SGMF telling you it's been run, and the report will be in the report section. So if we go back and look at that, just click on the back to the report section. And there we go. At the top there, AO442, demo of BASiL, and we'll download the report. So we'll just look through this briefly to see what is where. The first page of the report that you can see here is all about the information that you put in. So it should just be reflecting back to us what was said. So the project, demo of BASiL, and the run description, demo of BASiL, that's data we put in. The organization, this will be your company. Obviously, I'm SGMF, so it's come up SGMF staff. And that's the email or the username on the portal that's actually made the run. So admin in this particular case at SGMF. So the important page is page number 2. These are all the results. So at the top here again, we're just reflecting what the results are for. And the most important thing here is bottom left. These are your answers. Okay, so we're looking at a 9mm size hole in the hose, which gives us a leakage rate of 81 kilograms per second. And here are the safety distances. So if we look at the horizontal jet, this is coming out at sort of parallel to the ground or the sea surface. It's going 32 meters. If that goes upwards, it makes 11 meters before gravity takes over and it falls back down again. So these are the gas dispersion distances. We can see them in the diagram up here as the pink. That's the H1R1. So we can see it spreading all the way across the deck of the bunker vessel, but not across the gas-fueled ship, or again in plan. Remember, these are just indicative. The fact that we put a bunker station below deck means we don't get a complete circle over the deck because we've got a height difference between the two. Pool on land or pool on water. Well, obviously we've got no land here, so we're only interested in the pool of water. But if we had a road tanker, there could be a pool on land. So pool on water are 27 meters, so it doesn't quite go as far as the jet, and the height is only 4 meters. So we can see it at the end here, coming up through between the two vessels and spreading around at the ends. Across the deck, As I said earlier, it's not going the whole way. If we'd been on the deck, it would have gone 32 meters above the deck, but as we're below the deck, we get 14 meters. So there we go, our indicative drawing and our actual numbers. And it's the actual numbers that are important. When you sign up to use BASiL, SGMF sends you a book. The book's titled Recommendation of Controlled Zones During LNG Bunkering. Most of the answers about BASiL and the data that underlies it are within that publication. Also be aware that most of the detail is in the appendices, so you'll need to read them too. Other ways of interacting with BASiL, we have a BASiL community, and we want feedback from that community, and we hold occasional events talking about BASiL. BASiL is deliberately limited to stay within its database and therefore ensure accuracy. If what you want isn't available through the portal, talk to us. It might be possible. Thank you for taking the time to watch this video today. If you have any further questions, please do not hesitate to contact the team.